Hello everyone. Have you ever wondered how your smartphones, mobiles, the laptops and even the internet work so seamlessly? The answer lies in the magic of semiconductors. Let's unravel the mystery of semiconductors in today's session. What are semiconductors? Semiconductors are a very special class of materials whose conductivity lies between that of conductors as well as insulators. Semiconductors are the materials which have a conductivity and resistivity in between conductors and non-conductors or insulators. Semiconductors can be compounds such as gallium arsenide or pure elements such as germanium or silicon. So here we have two best examples of semiconductors which are the pure semiconductors, silicon and germanium. We can observe the electronic configuration of silicon as well as germanium, and we can find that these are the tetravalent elements which have 4 electrons in their outermost orbit. Come, let us study the properties of semiconductors. Semiconductors can conduct electricity under preferable conditions or circumstances. This unique property makes it an excellent material to conduct electricity in a controlled manner as required. Here, we can tune the properties of semiconductor as and when required. Either we can make it to behave like an insulator or an excellent conductor. It causes a certain number of valence electrons to cross the energy gap and jump into the conduction band, leaving an equal amount of unoccupied energy states, that is holes. Semiconductors act as insulators at 0 Kelvin, and on increasing temperatures it works as a conductor. On increasing temperature, the electrons in the valence band gain enough energy to cross the energy gap and reach the valence band. Due to their exceptional electrical properties, semiconductors can be modified by doping to make semiconductor devices suitable for energy conversion, switches and amplifiers. Still, there are many more applications of semiconductors. Semiconductors are the backbone of electronic industry and contributing for the development of technology. Very popularly, we all know about the Intel. Intel stands for Integrated Electronics, a company which manufactures processors for computers. So, Intel makes use of semiconductors to manufacture the chips, processors which are required for the processors. Now, let us go through the types of semiconductors. Semiconductors broadly can be classified as intrinsic semiconductors and extrinsic semiconductors. Once again, the extrinsic semiconductors can be further classified as P-type and N-type semiconductor. Intrinsic semiconductor are the pure semiconductors. Extrinsic semiconductors are the semiconductors which are obtained by the process of doping. Intrinsic semiconductors. An intrinsic type of semiconductor material is made to be very pure chemically. It is made up of only a single type of element. Germanium and silicon are the most common type of intrinsic semiconductor elements. These elements have 4 valence electrons. They are bound to the atom by covalent bond at absolute zero temperature. At absolute zero temperature, semiconductor behaves like an insulator. When temperature increases, due to collisions, few electrons are unbounded and become free to move through the lattice, thus creating an absence in its original position. On gaining energy, the electrons are free from the covalent bond and they start to move within the semiconducting material. When the temperature rises due to collisions, few electrons are unbounded and become free to move through the lattice, thus creating an absence or hole in its original position. These free electrons contribute towards the conductivity. These free electrons and as well as holes contribute to the conduction of electricity in the semiconductor. The negative and positive charge carriers are equal in number. So here we may observe that on gaining energy, an electron is free from the covalent bond. On gaining energy, an electron is free from the covalent bond and it starts to move within the semiconducting material. So this free electron is contributing for the conductivity, and we can also observe here, as soon as the electron is free from covalent bond, a vacancy or hole is created in its original position. To fill this vacancy, other electrons move to this position, thus conducting towards more conductivity. Next, let us move towards extrinsic semiconductor. The conductivity of extrinsic semiconductors can be greatly improved by introducing small number of suitable replacement atoms called impurities. On adding impurities, the conductivity of the semiconductors can be enhanced. The process of adding impurity atoms to pure semiconductors is called doping process. An extrinsic semiconductor can further be classified into N-type semiconductor and a P-type semiconductor. So this is about today's session. I hope today we have understood about what are semiconductors, what are the types of semiconductors, how the semiconductors are classified into. So further discussions on semiconductor will be carried on in the next part. Stay tuned. Thank you.